For video 3E, we're just going to do 3.12. You do not need to do 3.11. We are going to discuss isosceles and equilateral triangles. First of all, some properties. Let's do letter A here. The isosceles triangle. So first of all, let's go put this on here. A triangle is isosceles if and only if it has two legs that are congruent. This one need not be. It could be. Every equilateral is actually also an isosceles triangle, but not conversely. So these are the same measure, and let's pretend that's a 10 and that's a 10. Then we call this an isosceles triangle. And one property of an isosceles triangle is that its base angles are also congruent. So we can say this: if a triangle is isosceles, then its base angles are congruent. So if this is x, so is that. The converse of that is also true. If the base angles are congruent, then the triangle is isosceles. So it works both ways. Ugh, I always struggle spelling isosceles. It's a weird word. Weird word. Isosceles. So what it's saying is if you have a triangle and these two angles are marked congruent, you can conclude that these sides across for them are also congruent, and vice versa. So for an equilateral triangle, a triangle is equilateral if all of the sides are congruent. So again, if this is 10, and this is also 10. On this one could have been like 9. And what we know is that because all the sides are the same, the base angles are the same, and that would give me all of the angles the same. And in particular, if they're all the same, suppose this is x, and this is x, and this is x, I also know that the angles in a triangle add up to 180 degrees. We've discussed that already. So I'd have the three angles. Sorry about that, little glitch here. I'd have the three angle measures that have to total 180. So specifically, if the triangle is equilateral, I know that every angle is 60 degrees. So 60, 60, 60. So if a triangle is equilateral, all of its sides and all of its angles are congruent. It has three congruent sides and three, and I'm not going to write three congruent angles. I'm going to write 360-degree angles because that's a little bit more specific. So now let's go apply this and we'll be done. This says find the value of x. So let's look at what I've got marked here. I've got angle the same as this angle. I've got these two sides the same. And what that tells me is I have an isosceles triangle. For isosceles triangles, I know the base angles are the same. So now what I know is that these triangles are the same, and let's repeat why they're the same. I've got these being congruent, the left-hand side and the right-hand side, because I've just marked angle, side, angle. So the angle, side, angle congruence theorem says that these allows me to conclude that the triangles are congruent. Well, if the triangles are congruent, all their corresponding sides are congruent. So 4 has to be equal to x. I mean, it looks equal, and you're probably get it right if you guessed it's equal, but don't. All right, so on the next one, I'm looking for x again. I know I have an isosceles triangle because of these markings, so I can conclude that the base angles are the same. So if one of them's x, the other's x. Well, now I'm inside a triangle, and I know that the angles inside of a triangle have to add up to 180 degrees. So I get 40 plus twice x has to equal 180 degrees. So I get twice x has to equal 140 degrees, subtracting the 40 from both sides. And I get x is equal to 70. So what I know is the base angles on this triangle are 70 degrees. And if you look at it, all those angles, when added together, have a grand sum of 180. Last one, this will be a nice short video. So I'm going to walk my way around this triangle. I've got a couple things going on here. I know I have a right angle, so I know that angle 2 and the angle next to it have to add up to 90 degrees. I was also told that angle 2 is 4x minus 2. I'm solving for x. So if I could get this angle with the dot on it right next to each other, I could say that 4x minus 2 plus it has to equal 90. So let's go get it. I've got an isosceles triangle as indicated by these being the same. If those are the same, then the base angles, the ones across from those sides, are also the same. So now I'm in a triangle. I've got 68 degrees and another 68 degrees at the bottom of that triangle for 136 degrees. The angles in a triangle add up to 180. So if I remove that 136 from 180, I get 44 degrees up here at the top. Well, I also have a little right angle box up there. So I know that 4x minus 2 plus the 44 degrees has to equal 90. And again, it's 90 because of that box that they gave me in that corner. So I've got 4x plus 42 has to equal 90. That gives me 4x has to equal 48, subtracting the 42 from both sides. Dividing both sides by 4 gives me an x, or a final answer, of 12. Have a good one. Peace out, Girl Scout.